All right, we're going to talk about applications of linear equations. And with that, a lot of times we need to talk about story problems. I know a lot of you don't like word problems, but they are a necessity. So the first thing is when we're talking about our strategy for word problems, what we want to do is we want to make sure that we read the problem carefully several times, okay? You need to read it enough times until you can state in your own words what is given and what the problem is looking for, okay? Then you're going to let x or any variable represent one of the unknown quantities, okay? So you might have to reread the problem several times, multiple times, okay? So step 2, write expressions for any other unknown quantities in the problem in terms of x. So we're going to try and write all these basically algebraic expression in terms of x. Then you want to solve the equation and answer the problem's questions. We want to know if that, answer it, okay? So we're trying to solve that for the answer. And then number 4 is check the solution. So checking is not just, did you get a numeric answer? It's also making sure that the answer makes sense. So, make sure that makes sense. We don't want the height of a fence to be, 30,000 feet. That's not very realistic. We also don't want it to be like 3 inches tall, okay? So you need to make sure that it makes sense. Check your answer. Take your answer, plug it back in if you can, okay? So we're going to do a couple examples here. We have 3 of them up here. We have a couple of word problems here. I will read them off to you. You are choosing between 2 phone plans. Plan A costs $20 per month with a 5-cent charge per text. Plan B costs $5 per month with a 10-cent charge per text. For how many texts will the cost be the same? Now, this is kind of a older type problem when we charge per text, but it gives you an idea of it. So let's look at plan A. So plan A, so what am I looking at? What am I being charged for? Well, I'm being charged for text. So x equals texts. So it's the number of texts, okay? So plan A says, okay, it's going to cost $20 plus 5 cents per text, okay? And then I have plan B, which is $5 per month and 10 cents per text. And we want to find out when those are equal. So we're going to take these and set them equal because it says for how many texts will the cost be the same. So I want plan A to equal plan B. So I'm going to go 20 plus 0.05x equals 5 times 0.1x. Okay, so now I'm going to subtract off, that's not supposed to be an x, that's supposed to be a plus, 5 from both sides, so I get 15. I'm going to subtract off 0.05x from both sides, and I get 15 equals 0.05x. Okay, now my last step is I'm going to divide by 0.05. I'm going to divide by 0.05. And this, when I divide this out, is 300. So at 300 texts, these plans are the same. Okay? If I have under 300 texts, plan B will be cheaper. If I have over 300 texts, plan A is going to be cheaper. Okay? 300 texts. Some of you are probably like, that's going to happen in one day. Now, our next one, it says a camera that costs $276 is on sale for 40% off. What is the new cost of the camera? I'm going to show you 2 different ways to do this problem. Okay? So the first thing is, I'm going to come up here and I'm going to go, okay, so my original price, so this is cost, my original price minus my percentage off, 0.4 times 276, okay? So I want to have my original cost minus my discount, okay? So 276 minus 0.4 times 276, and I get a new price of $165.60, okay? So what I did here is I took my percentage off. I multiplied it by the item and then subtracted that from my original. Now there is another way to do this, okay? And so if I look at this, the other way is I can sit here and I can go, well, if I have 40% off, my cost is how much percentage of the original? Well, it's 60%. So I can actually go 0.6 times 276, and I get the exact same item, which makes sense, right? So I have, and this is just an extension from here to here, because I have 276, I can pull those out. Now, this is the one that is very important, is being able to take a formula and solve for a given variable, okay? So it's very important that we can be able to solve for it. So I am solving for L. That means I have to isolate L on one side of my equation. It doesn't matter which side, I just have to isolate it. So I look to see where there's an L, and I'm going to take that and I'm going to move everything else to the other side. So I'm going to subtract off 2W from both sides. Now, I can't subtract 2W from P, so I just leave it as P minus 2W equals 2L. Okay? Now, what else is attached to the L? Well, there's a 2, so I'm going to divide this side by 2, which means I have to divide this side by 2. I'm also going to flip the directions. Remember, we can do that. The commutative property says it doesn't really matter what side on the equal sign it is. So now I have L equals P minus 2W over 2. There's my new formula for L. So this is, essentially this is the perimeter for a rectangle. Now I can find the length of a rectangle given the perimeter and the width. Okay, so that's kind of applications of linear, kind of talking about word problems.